Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 11 to 15 of the January 2019 Algebra 1 New York Regents released exams. Alright, let's take a look at question 11. In this problem, we're going to be looking at how to evaluate an expression using two or more expressions. Alright, so it reads, if c equals 2a squared minus 5 and d equals 3 minus a, then the expression c minus 2d equals. So let's go ahead and start by specifying what c and d are. So in this problem, c is 2a squared minus 5 and d is 3 minus a. Okay? And then we have to evaluate this formula expression c minus 2d using these two pieces of information. Now all we're simply going to do here is we're going to take the c value, which is 2a squared minus 5, and we're going to substitute it for c in this expression. And then we're going to take the d value, which is 3 minus a, and substitute it for d in this expression right here, and then evaluate. Alright, so something to keep in mind, a tip for the Regents exam, and this tip is concerning substitution in parentheses. What's the tip? The tip is as follows. You always want to use parentheses, so always use parentheses when substituting. Okay? The reason why you want to always use parentheses when substituting is it helps you avoid making errors associated with sign and exponentiation. Okay? Alright, and another word of caution, something that you really want to keep in mind, caution, this has to do with having negative in front of parentheses. Okay, so you want to watch out for the negative sign in front of parentheses. With expressions inside. The reason being that signs change whenever you have a minus in front of a parenthesis. I'm going to illustrate that to you right now. Okay, so we're going to start out by taking out these two variables c and d. We're going to replace them with parentheses. Okay, so in place of c, I'll put parentheses minus 2 times parentheses. Now I was going to go in the first parenthesis. I took c out. I'm going to substitute this expression right here for c, which is 2a squared minus 5. This parenthesis doesn't have any minus in front of it, so this caution that I indicated here doesn't apply. For d, though, we're going to substitute 3 minus a. But notice we have a minus in front of this parenthesis, so you always want to watch out for those because you want to make sure that that sign is distributed. Okay? So 2a squared minus 5, you can imagine as though there is an invisible coefficient here, which is just 1. So when you distribute that positive 1 across these two terms, nothing happens. So it just remains 2a squared minus 5. Now on the right side, we are not just distributing the 2, we're distributing negative 2. Okay? So negative 2 will be distributed to positive 3 and negative a. And as indicated earlier, when you distribute to negatives, signs do change. Okay, so negative 2 times 3 will give us negative 6, and then negative 2 times negative a will give us positive 2a. Alright, now we're going to combine like terms. We'll drop down any term without any like terms to be combined with, starting with the highest degree term. The highest degree term here is 2a squared. The degree of this term is 2. So it's 2a squared. There's nothing to be combined with that. 2a, the first degree term, has nothing to be combined with, so we just bring it down. The constants, also known as your 0-degree terms, there are two of them that can be combined. So minus 5, minus 6, the signs are different, so what are we going to do? If the signs are different, you're simply going to add the numbers and keep the sign. Okay, so it remains negative. 5 plus 6 is 11. So your answer is 2a squared plus 2a minus 11. Answer to this problem when evaluating expressions with expressions is option, let's see, option number, see, 2a squared plus 2a minus 11, option number 3. Alright, let's take a look at question number 12. In this particular problem, we're going to be looking at how to generate exponential models, either growth or decay, using tables. So we have a table of values here, and we're going to be creating an exponential model. So the question reads, Mark bought a new laptop for $1,250. He kept track of the value of the laptop over the next 3 years as shown in the table below. Question, which function can be used to determine the value of the laptop for X years after the purchase? Alright, to get us started, we're going to write down what the formulas for exponential growth and decay are. So let's put that to the side, our formulas. This is for exponential growth and decay. Alright, there are two forms for exponential growth and decay models. The first is known as the factor form. Okay, so the factor form is given by y equals ab to the x. Alright, this is known as the factor form. It's a factor form because it's written in terms of the growth or decay factor. Okay, so for example, if the b value, this is known as b is the decay constant. Alright. Oh, sorry, it's the growth or decay factor. Okay, so b is a growth or decay factor. So which is which? If b were between 0 and 1, so if 0 is less than b and less than 1, in that case, we're going to have a decay model. Alright, so this would be a decay model. And then if b were greater than 1, in that case, we're going to have a growth model. Alright, so the value of the growth or decay factor basically tells us if it's going to be a growth or decay situation. Alright, so B is your growth or decay factor. That's why it's called a factor form. This is the form we're going to be using for this problem. If you look at all the format of the alternatives that we have, they are all in the form f of x equals some constant times the base raised to the x power. Alright, the other one is known as the rate form. The rate form is as follows. The rate form is basically y equals a times 1 plus or minus the rate raised to the x power. Okay, so this is the rate form. Why is it the rate form? Well, just looking at it, you can easily tell what the rate is. Or if you have the rate, the decay rate or growth rate, you can generate this model using this formula right here. All right. So if it's a growth scenario, if the output is increasing, in that case, you're going to have 1 plus the growth rate. Okay, so 1 plus r is a growth model. And then 1 minus r, guess what that is? That's going to be a decay model also. Alrighty? Okay. So that's that. So let's just put a side note here, something to note. The connection between these two, they're one and the same. Something to note is that your growth or decay factor b is equal to 1 plus or minus the rate, depending on if it's growth or decay. Alright? Okay, so let's look at what we have here. First of all, I'm going to show you the quick way to do this, and then we'll go over all the steps so that you can see how to do it in detail. So if you just observe what's happening here, you notice that um, years after purchase, we have 1,000. 1 year after is 1,800,640. What's happening is that the amount is doing what? Is it going up or down? The amount is going down, which indicates a decay. Okay, so it's decreasing, which indicates decay. So from that alone, we can know that the growth rate has to be between 0 and 1. Okay, so if you look at the options that we have here, option 1, the um, the factor here, this is going to be a growth factor. This is greater than 1, so this is a growth model. So it cannot be option 1 because of this. This is a growth rate right here. I mean a growth factor. And then if you look at option 2, this looks good because it's decay. Because 0.8 is between 0 and 1. And if you look at number 3, the growth factor, this is a growth factor because the base of this exponential term is greater than 1, so that's increasing, so that cannot be the answer. And this is a potential answer because the base of the exponent is less than 1, which indicates that it is a decay factor, which indicates decreasing. Okay, so just by looking at the base of the exponents, the base of the exponential terms, you can easily determine if it's growth or decay. So we eliminated 1 and 3 because the bases are greater than 1, which indicate growth models, and we kept 2 and 3. I mean 2 and 4. Now to know what the final answer is, just think about what was the original amount, the original price. The original price was 1250. So whichever one has 1250 and it's a decay model, answer is option 4. Alright, so that's just a quick way to do it. Just look at the table, is it increasing or decreasing, and then look at the initial amount and you can generate the answer. Alrighty, okay, so let's go ahead and do it step by step. First things first, we have our formula already. The formula is y equals ab to the x power. Let's find what b is first. So b is your, in this case is decay, so it's your decay factor. To find what the decay factor is, you just simply take y2 and divide it by y1, or you can take y3 and divide it by y2. It doesn't really matter. So we're going to take 800 divided by 1000. This is y1, this is y2, this is y3. We're trying to figure out what are we multiplying by every single time. Okay, so this is 8 over 10. And you can write this in fractional form. Just move the decimal point one place to the left for both of them. And in decimal form, this is 0.8. Or you could do it with your calculator. 800 over 1000 will give you 0.8. Alright, so this is the decay factor. Alright, A is the original amount. What is the original amount? The original amount or original price was 1,250. So we'll just take these two values and plug it into the exponential decay model, growth or decay model, or the factor form of exponential models. Let's go ahead and do that. So we have the model again is y equals a b to the x. And then if we substitute for a, we put in 1250. And the base b, the decay factor, is 0.8 raised to the x power. We can clearly see that our answer is option number 4. Okay, so that's that. Alright, let's take a look at question number 13. In this problem, we're going to learn how to read projectile motion equations. Question 13 reads, the height of a boulder seen tossed into the air can be modeled by the function h of x equals negative 4.9x squared plus 6x plus 5, where x is the time elapsed in seconds and h of x is the height in meters. The number 5 in the function represents, so we have four options here. To get us started, let's go ahead and specify what the projectile motion equation is, and then we can identify what the different components are. All right. So formula is as follows. Let's put it. Yeah. Okay. All right. So the formula. This formula is for your projectile motion. Projectile motion. Alright, so your projectile motion equation is h of x. Sometimes it's written in terms of t. The independent variable here is x, so we're going to use x. H of x equals negative 1/2 gt. Let's use x. I said I was going to use x. 1/2 gx squared plus v sub 0 x plus h sub 0. Alright, now what do the different variables here mean? Let's start with g. G basically represents acceleration due to gravity. Acceleration due to gravity. Any object that's within the gravitational pull of the Earth will accelerate towards the center of the Earth. Okay? It's downwards or towards the center of the Earth. That's why we have a negative sign. Now, how about the v sub 0? The v sub 0 basically means this initial or starting velocity. So v for velocity. Initial or starting velocity. And then we have h sub 0. H sub 0. This sub 0 basically means start, okay? H sub 0 represents your initial or starting height. How far was the projectile before it was tossed into the air or dropped towards the ground? Initial or starting height. And then x represents the time in the air. And then h of x represents the height. Height from the ground. Height from the ground at any time x. At any time x. Okay? Alright. So just by setting these two equations, placing them next to each other, and mapping variables to constants, we can easily determine what the number 5 is. Alright, so let's go ahead and write down the function first that's given in the problem. So h of x is negative 4.9x squared plus 6x plus 5. And then let's put the formula underneath and then see what the 5 stands for. Okay, so h of x, we're going to write down this formula that we just wrote here, is negative 1/2 gx squared plus v sub 0x plus h sub 0. Okay, let's go ahead and map it. So we can see that 4.9 is basically half of the acceleration. So 1/2 g is 4.9. We can see that 6 is your initial velocity. The coefficient of x is your initial or starting velocity. The coefficient of x squared is half of the acceleration due to gravity, and the constant is h sub 0. Alright, so we can clearly see that h sub 0 equals 5. And what is h sub 0? We specified it here. It's the initial height. Okay, so 5 represents the initial. Initial is the same thing as starting, okay? Initial or starting height of the ball. Height of the ball. And that is option number 1. Okay, so for number one, that's h sub 0, the h sub 0 value. Now let's attack the other options, okay? They are important for you to know because on your Regents exam, you might be asked to find the other components. Alright, so for initial height, that's h sub 0. Now, what if you want to find the time at which the ball reaches the ground? When the ball reaches the ground, the height from the ground is going to be 0. So in that case, for number 2, you want to solve when h of x is equal to 0. You want to solve that equation, or you want to find the zeros using a graphing calculator of this equation right here. For option 3, the time at which the ball is at its highest point. In order to figure that out, you simply use the formula negative b over 2a. Okay, so that's it right there. And then the last one, to get the maximum height, all you just have to do here is for number 4, you evaluate the function at the maximum time. So h of negative b over 2a will help you find what the maximum height is. Alright, so that's how to find the other parts of this projectile motion equation problem. Alright, let's take a look at question number 14. In question 14, we're going to be learning how to find the range of a function using the specified domain and the function in algebraic form. Okay, the question reads, the function f of x equals 2x squared plus 6x minus 12 has a domain consisting of integers from -1 to -2 to 1 inclusive. So basically we add the endpoints. Which set represents the corresponding range values for f of x? Okay. Alright, so we remember what integers are, right? So integers are basically whole numbers, 0 and their opposites. So let's recall that. Let's note that down so we don't forget. Recall the following. Recall the following concerning integers. Integers are whole numbers, 0 and their opposites. Okay, so what am I talking about here? Whole numbers, 0 and their opposites. Integers are 0 plus or minus 1 plus or minus 2 plus or minus 3, and goes on and on forever. Alright, so those are what integers are. Now let's go ahead and also note something that we have to do when you're writing elements of a set. When you're writing elements of a set, remember that you do not repeat elements, and you order it in increasing order. Alright, so keep that in mind. Alright, so let's note that down. Something to note concerning the set notation. What do you want to note? You want to note that elements are ordered. Elements are ordered, and there are no repetitions. No repetitions. Okay, you'll understand what I'm talking about in a second. So let's go ahead and start off by writing down what the function is. So the function is 2x squared plus 6x minus 12. Okay, and the domain are integers from -2 to 1 inclusive. So what are we looking at? We're basically looking at -2, -1, 0, and 1. All right. So how do we find the range? The range is basically what you get when you input the domain values into the function. So the range values are going to be the function evaluated at -2, the function evaluated at -1, the function evaluated at 0, and the function evaluated at 1. Okay? You can do this by hand. You just simply plug in these values into this function and use your order of operations to simplify. But since the use of a calculator is permitted on this test, we're going to use it to expedite the computation process. Okay? So for y1, we're going to put in the function 2x squared plus 6x minus 12. Enter. So we just need the values from -2 to 1, so we can go to table setup. It tells us where to start from. So table start, let's start from -2, and it will be increasing by 1. Since we're going by integers, increase by 1. Okay? Enter. So let's see what the table looks like. This is what the table looks like. So -2 is -16, -1 is -16, 0 is -12, 1 is -4. So let's write that down. We have -16, -16, and what was the other one again? Let's see. -12 and -4. Alright, -12 and -4. Now, if you want to write this in set notation, how are we going to organize these elements? Remember what we indicated earlier, that they have to be ordered in increasing order and there are no repetitions. Okay, so which is the smallest one? -16. So we start the range using set notation. Is going to start with the smallest, -16. We have two -16s, but in set notation you do not repeat identical elements. Increasing to -12 and then -4. Ladies and gentlemen, this is the range given this domain from -2 to 1 inclusive. The answer to question 14 is option number 2. Alright, let's take a look at question 15. And question 15 in this problem, you're assessed on how to transform quadratics by completing the square or by expansion. Okay? Alright. The question reads, which equation has the same solutions as x squared plus 8x minus 33 equals 0? So there are two methods we're going to use for this problem. The first method involves going from the expanded form into the factored form. And then the other method will involve going from the factored form into the expanded form. The difference is the first method, we are going to be going from the question to the answer. Alright, so that's method 1. Let's go ahead and write that down. Method 1. Method 1 is your completing the square method. It's called completing the square. Okay, for completing the square, you're going from the question to the answer. The question is x squared plus 8x minus 33 equals 0. So first things first, we want to create an incomplete square on the left side. So in order to accomplish this 33 needs to go to the right side. So we move the constant over. We're trying to create a perfect square trinomial. Okay, so we have x squared plus 8x, and we need a term here to make this a perfect square trinomial. But whatever term we insert in this spot to make the left side a perfect square trinomial, we have to add exactly the same thing to the right side. So what are we going to use to complete this square, to make this a perfect square trinomial? Well, what you have to do is you want to add b over 2 square. So that's how you complete the square. You add b over 2 square to both sides. Okay, let's do it. So we're going to have x squared plus 8x plus b over 2 square. And then we added that to the left side, so we're going to do the same to the right side. 33 plus b over 2 square. Okay, so what on earth is b over 2? Now, if you look at this equation right here, the coefficient of the x squared is a, that's a, and the coefficient of x is b. Okay, so let's figure out what b over 2 square is on the side here. B is 8. So when you divide it by 2, that's going to give us 4. So b over 2 square is 4 square, which is 16. So that's what completes the square. On the left side, we have x squared plus 8x plus 16. This is a perfect square trinomial. And on the right side, 33 plus that 16. That resulted from completing the square on the left side. Now to factor the left side, since it's a perfect square trinomial, we're going to use a factorization shortcut. We factor the first term and the last term and bring down the middle sign. Okay, so the factored form is going to be x plus square root of 16 is 4, quantity square. Okay, and on the right side, 33 plus 16 is 49. So the answer to question 15 is option number 1. Alright, so this is a factor method. Completing the square method, which is a little bit involved. You need to know what the algorithm is. You need to know your steps and the factorization techniques needed here in order to do it. Now let's assume that you do not know how to complete the square. Well, you resort to method 2, which is pretty familiar to most. Method 2 is your expansion method. Okay, so for method 2, we're going to expand. And what we're doing is we're going from question answer to question. The penalty here is that we have to keep expanding until we get to the correct answer. So we are doing it blindly. We don't know what the correct answer is. Alright, but in completing the square, we're going, it's a direct shot. We're going from the question, and if we do it correctly, we just hit the answer. But when we're doing the reverse, we're just expanding these to see which one results in this when placed in standard form. Okay, so let's start with option 1. What do you think will happen with this one right here? X plus 4 squared. Do you think if we expand it completely and put it in the standard form that it will be the same as this? Well, it should be, because that's what we got using method 1, right? If not, there is going to be a problem. Alright, so we'll start by getting rid of this parenthesis. Notice the standard form has no parenthesis in it, so we will multiply x plus 4 by itself, and that equals 49. So you're multiplying two binomials, so you can just FOIL it out. First, outer, inner, and then last. Double distribution. Bam. Now when you multiply, you're going to have x times x is x squared. That's first. Outer x times 4x is plus 4x. Outer, inner, 4 times x is 4x. Last, 4 times 4 is 16 equals 49. Now let's combine like terms. Positive 4x and positive 4x are your first degree terms, so we combine those. And then we have x squared plus 8x plus 16 equals 49. Our target expression has a 0 on the right side, so to make this 0, we have to subtract 49 from both sides of the equation, and that will give us our desired result. If we carry out the subtraction, we are going to get x squared plus 8x, and then if you do that with your calculator, you get minus 33 equals 0, and this is a match, so the answer is option number 1. Now had it been that we got something that doesn't match the original quadratic equation, then that will mean that either that's the wrong answer or we did it incorrectly. Hopefully the first is the case, that it's not the answer, and then we just move on to the next one and expand. So when you expand all of them, you will definitely end up with 1 if you did it correctly, and the one that matches the question is the correct answer. Alright, so this is how you transform quadratic equations from expanded form into factored form. Thanks so much for taking the time to watch this presentation. Let us know what you think. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions, comments, or special requests, feel free to post it in the comment section below. Don't forget to subscribe to our channel for updates to the remainder of this review series. More support resources can be found at mathgotserved.com under the New York Regents page. Thanks again for watching and have a wonderful day. Goodbye.